Hey guys, it's Kevin. Today we're going to re-engineering Epson Printhead. We'll take this printhead, strip off its cover and look underneath. We're going to also work on under the microscope and decipher the inner side of the printhead. Eventually, we're going to build our own schema. You usually see this printhead in your Epson EcoTank printers, such as ET2750. You're going to see those 4 heat sealed corner. Okay, there are 4 tabs. We're going to hold a corner and push on this, the top tab. See, that one got released. We do the same for the 3 other corners. Just grab it and push it up. Very easily, that tab gonna fall off. We keep going and do the same for the other 2. You can see one side is the manifold, the other side is the metal mesh, which most of clocks stopped at this metal mesh. Okay, I'm gonna clean it off and continue. Now we're going to separate this metal mesh plate from the printhead itself. So just grab the corner and lift up. You get 4 more heat sealed tabs. This is the printhead itself after you remove the ink system. And those 4 holes where the ink goes in. And you have a PCB board. And the yellow ribbon is from those FFC cables. It connect to those yellow ribbon, and the yellow ribbon connect to a crystal assembly. It is a part of piezoelectric actuator assembly. You tore the top, maybe 4/5 of them off. Basically, it's the assembly without the piezo plate. Sometimes you pull it off with a PCB board. This one we'll pull it off cleanly. It's inside here, and both of them still connected to the piezo plate. If they're still in there, you can remove the nozzle plate and get them out. See, this one I pull out the crystal with the PCB board. There's just one of them connected. There will be 2 of those, and they sit vertically and connected to the PCB board with FFC ribbon. If you need to remove the FFC ribbon, you can just apply some heat. The FFC ribbon will be detached. Okay, let's take a look of this assembly. This is the FFC to the PCB board that we torn off. And those ground wire, power wire, and signal wires goes to this big IC. After IC fires up all those wires, and this shaded region, they are tiny wires, and each wire connect to electrode trace. The electrode trace look like a silver comb, which when you tear it off, you probably tear it off from here. The bottom kind of will draw it upside down, and so here's the electrode trace, the silver comb comes in. We have a flexible polyimide layer, and after that, there are the piezo plate, and on the top of piezo plate is what you're familiar nozzle plate, the metal plate with little holes. Alright, we're just going to use our phone, take a picture of the crystal, and take a picture of this assembly, and we import it into Photoshop, and now we can zoom in and zoom out when we need it. Now we're going to work on the PCB board and get your fire going, add some water, and I'm going to just literally drop the PCB board in it, and get 1 teaspoon of the finest cocaine. Actually, it's not cocaine. I'm going to put a link to that white powder in the description of this video. And then I go run like 2 miles and come back. By the way, if you want to talk to me, I run every morning, and the time is not determined, so I just start running and I do a live broadcast. If you have a question, you can ask me live. I only do it during the work days, okay? Yeah, if you come to our repair shop and you're going to see lots of toothbrush laying around, do not just pick one and brush your teeth, okay?
Make sure you wear protective gears.
You might notice I already desoldered all the components. It's because I have so many boards laying around, so I can desolder one and remove the mask, so I can compare with the one with solder device on it. But for you, you would like to take a picture of the whole board before you desolder it and save as an image file. Then when you desolder a component, you use a tape it on the printout of the board. And then you can start running again. And we're going to take a picture on the iPhone. Make sure it says flat when you take pictures. All right, so we open up Photoshop. Then we import the first picture of the one with a mask on. And for the FFC, we're going to create a text to mark the FFC. So there'll be 1 and 2, 10, and 11 to 20 and 21. And I suggest the font to be Courier New because equal space. Then we insert a second layer, which is the one without mask. And you have to line up all the holes of the two boards. And let's say this is the board I want to line up. So you have one board that's standard. Okay. So on the board above, you can do Control and T, which is transform, or you can just go here, image, or the transform. There's transform. And then we're going to set the opacity to about 70, 80, so we can see through it. Okay, so you can see right now if I change this, I have a target to line up. And also your picture are going to be distorted when you use the phone to take a picture. So we're going to edit, transform, and we're going to do a skew. You either do a skew or distort. If you don't know the difference, just go Google it. What's the difference between skew and distort? So I do a skew. So I only work on this region to line up those two. So I can line up this two, and then I move corner, and the whole thing will line up. Okay. So we can turn this mask on and off, and trace the front. And then we're going to import the back of the board. However, because now you're looking at the back, you have to flip this horizontal. So you go image layer, image rotation, and you flip this canvas horizontal. So for example, this is watching real life. Okay, you take a picture and import this. Then after import, you have to go image rotation, flip horizontal. So basically what this is, if you can see through stuff like X-ray, you look from the top, you look down, this is what the board look like. Okay, and the same thing as here, you remove the mask and also you flip horizontal. So what this can do is, for example, this is top down from the top view. So if I remove this top view, underneath that top view, and just look at, let's say we're going to look at this hole here, and then we collect this and this hole right here. Okay, so look at this hole. So if I just say, hey, underneath what it look like. So in this layer, and here's what underneath that hole look like. So basically this board is connected underneath here, and so these 2 points are connected. Okay, that's why you have to flip. Now we import the picture that we took for the crystal. So there are 2 crystals. One is the bottom one, so we line them up. We're going to line them up with the opacity 70%. We're going to line them up with the bottom of the FFC connections. Oh, by the way, yeah, if you don't see, the connection is underneath. So here's what it looked like. Right, so this is the bottom connection lined up there. Yeah, you need to flip the crystal too, because you're like looking at it the other way. Okay, on the top we also flip. Then we're going to download and install this software called KiCad. And let me see, it is free and nothing beats that. So we're going to create a couple of symbols. So we're going to go to the symbol editor. At first, you probably want to create your own library. I already created a library called BCH something. Here you can go to a new library, but I already did my library. And we're going to create a connection pins. I already created, so I basically you just lay 21 pins. So to be able to do it, you just add a pin, and it will create a pin name. For example, I create a pin number 22. Okay, and this one I don't have. So for example, this may be command 22. It look like this, and I want to be input. Orientation, where I want to be up. Actually, I want to be down. So if I add a pin, I just put it here. Okay, you can just save it. Click save, give my name. Okay, this is going to represent this FFC connection input here. And the next one, we're going to draw this crystal. And for this crystal, you get a plus sign here, and you get a 1 extra line here, and this is the negative. And remember, we flip this horizontal. We flip the picture horizontal. So when we draw it, we have to draw the round button here, plus sign on the left, and 1 extra line on the right. Let me just show you the picture. So on the picture, which you flipped, so you got a round here, got 1 extra line here. Okay, so we want to draw according to the real life will look like. So this is the correct way and flip. Drawing is very easy. You get a square, rectangle, and then you draw a couple squares, and you can draw lines across it. And after you draw these pictures, then you just add, remember we did add a pin, so we just go here and add a pin number 1, boom, and then we add a pin to it. Now we can close the symbol editor. The KiCad is really weird. It's multiple applications into one. We just created 2 symbols in the symbol editor. Now we can go to Schematic editor. And the first one, we want to add 2 symbols we made. We want to add 21 connections. There are 2 crystals, 1, okay, and on the crystal on the bottom, we're gonna call it bottom. And I see in the picture we see it this way. So this is the bottom one. The top one look at this way. Okay, easier if I put this one. This is how the top one got connected. Let's configure the bottom one first. So the bottom one, we flipped the extra line, and the negative is on the left. So the bottom one, we look this way, and we just need to flip it. So we want this extra line on the right, which is a mirror X. And let me just give you look. And also the FC connection is from the bottom up. So you want the orientation be 180. Okay, it's the connection on the bottom, and width need to flip. The actual line is on the left. The actual line on the left and the negative on the left. Nope. Yeah, this is good. This is good representation of what we see here. And here is the one on the top. So the actual line is on the right, and the negative is on the right. So negative should be on the right. So we need to flip this. Mirror X. Shit. Does it work? Yeah, I should mirror X first, and yeah, when I mirror it, the orientation got a knock off. Okay, now it's good. So the negative is on the right, and FFC points up. FFC points up, and the negative is on the right, and the actual line is on the right. Okay. Now we're ready to get the file started. The best is yet to come.
The best is yet to come.
Right, now we start with the first line. So if we look here, so the first line goes in here and go all the way here. The first connector is here, and I get a through hole here. Maybe we'll fill with blue, so easier for us. One, and goes here. Okay. Now we got two eclipse. This eclipse is the one. We can delete it. So there are two holes for the one. Now we can go see what the bottom look like. Where do those two holes go? So first hole is here, and go all the way here. And the second one is right here. Now we know the first pin goes to 1, 2, 3. Third one here, and the second one here. Let's take a look at the bottom pH. It look like this. So in the KiCad, we select a pin. We want the first one select to be the third one here. Second one here. So basically this assembly goes to this one and this one. If those step too much, you can go to BCH Technologies.com and looking for FA04000. I have all the file here for you to download. You're going to get the Photoshop file and the symbols, and also have a completed schema with all the inputs marked on the FFC input and also on the crystal assembly. So you can compare your work to mine. And this is really helpful for your troubleshooting. When you do the repair, you can figure out which pin is to which function. Now we can delete those clips. Get the second pin. Second pin, that's connector here, goes to here. What's here? is a brown capacitor. And this capacitor goes to here and goes to here. And if we trace here, it goes to number 3 O's and a big chunk of the PCB board. And here, if you see this, get this huge piece of metal, that means it's ground. So basically this second one goes to a capacitor, then capacitor goes to the ground. And then we have to take a look of here. Here goes to here, and now goes back to the top of, right, and here goes to here. I told you it's fun. This go back to the bottom here. Here goes, that one is on the way. Okay, so this one goes to here and also goes to here. Okay, and let's see what's on the bottom of this. Here goes to here. Ooh, it's like okay. Let's take a look of the real thing. Ooh, it goes to basically goes to those two big guys. It goes to capacitor. Capacitor goes to ground, and also goes to those two big guys on the side. Right. The second one, I'll make a ground here. Earth ground or real ground, it doesn't matter. I'll just do a ground here. And the second one, goes to capacitor. The capacitor goes to the ground. Okay, and before it goes to the, and also other than connect to a capacitor, is also connect to this guy and this guy. Okay, now we can delete all those eclipse. And let's see number 3. Number 3, and you can see is on the ground, and number 3 is the ground. And now we go to the number 4. Before we go to number 4, let's mark what we found out. So basically those two big guys, they're the ground. And the ground number 1, they're the ground for this thing. You have multiple grounds. On the pin here, we're going to call the ground number 2. So we'll call this ground number 1. And we want to go, so we're going to the symbol editor. No, we right click here and go to the symbol editor. And we know number 2. Remember we didn't have name, so now we name ground number 2. So we know in the future when we connect to it, this ground number 2. Save it. And I forgot what number 1 is. Okay, and number 3 we know is ground. We just call it GND. And this is the ground for this PCB board, or we call it ground PCB. It's up to you. And then we save, close. And we're going to right click, say update symbol. Now we're on pin number 4. Number 4, we have a hole here. It goes to here. What the hell is on top of it? Okay. So here it gets a capacitor. Hard. This goes to there, and here's. Oh, by the way, you also want to mark all the components. For example, so I mark 1, 2, 3, 4. So this will be connect to R10, the resistor 10. This bit bigger. So number 4 connect to R10. And R10 connects to R10 goes here, connect to this. And that there is the PNP. Okay. And the other side is rather here the connection R10. Another side I connect to a capacitor. Number 2 will be, and the capacitor number 2 goes to ground. Right. So let's do this. So number 4. Connects to a capacitor. I'll just copy and this capacitor number 2. And this goes to ground. And another one I need is PMP. This up a little bit. Yeah, maybe not. Okay. Now we can go number 5. Here. Here. What is there? That's a capacitor number 3. That's the emitter for the PMP. And let's get the hole here. Got the hole here. What is there? So the hole here goes to here. And I gotta come back here. 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 What was here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I got a 6 of those. 6 pin of this. So basically it goes to here, go to and then goes to here. And this one go to number 6. All right. 5 goes to emitter. I need to reread it. 5. And this number 3 is also a capacitor. Goes to C3. C3 to the ground. Okay. C3 to the ground. And then it goes to the emitter. And emitter goes to let me think of them. Okay, I need to delete those, rethink. Five. Okay, let me put this one here. 5 goes to, this is the capacitor, and this is the emitter. Okay. And that one goes away to 1, 2, 3, 4, 5, 6. That one goes. This one goes to here. One, 2, 3, 4, 5, 6. Okay, now got it. 5. 1, 2, 3, 4, 5, 6. All right. Okay, on the other side, number 5, this is just a test point. So this test point 5. Yeah, you can create another number is the test points. And the test point is which pin you're testing. Okay, now we can delete those. We'll see number 6 and number 7, they're grounds. Alright folks, I got really tired. It has been sitting there for a couple hours. And I think I just keep working for a few more minutes. You guys get the idea how to reconstruct this already. And if you can, just download my final file and of all the power inputs, signal inputs, grounds marked. And remember, you don't only have one ground, you get 3. Okay, first ground is the ground on the PCB board. Okay, that's like pin number 6, number 7 that I just showed. There's another ground with those 2 big arms on the crystal. And then there's a third ground is only for that driver chip in the middle. So you got 3 grounds total. Alright, I hope you guys enjoyed the video. Visit us at bchtechnologies.com or locally, Greensboro, North Carolina. Cheers. Here. This go to ground.